boys and girls, welcome back once again to our lesson. Like we ended on the equation of the least square regression line, how to plot it in the data and draw the line of best fit. Now, on the same vein, they can ask you to use the equation of the least square regression line to predict what will happen. For instance, let's say they give you if x is equal to say 7, and they ask you to predict the value of y. So in that case, if they have given you any x value, you just substitute into the equation of the least square regression line to predict y. So you say predicted y is equals to 5,66 plus 0,88, then you open a bracket, then you put 7. So from there you press on your calculator, and then you are going to get your answer as therefore your predicted y is equal to 11,82. Predicted y is equal to 11,82 to do 2 decimal places. So that's how you go about it. And if they want you to write it in the nearest whole number, then you can say it's equivalent to 12. So therefore, your predicted y is equal to 12. Otherwise, if they have not asked you to leave your answer in the nearest whole number, you can leave your answer at 11,82. So that is what we call scatter plot diagram and the questions that follows. From there, we are now going to look into what we call the correlation coefficient. The correlation coefficient R. Our correlation coefficient. So let's take note of that. We'll be looking at our correlation coefficient R. So when we talk about the correlation coefficient, we are looking at the value between R is in between -1 less than R and less than 1. This is where correlation coefficient relies. Correlation coefficient. So that is what we term as R. Correlation coefficient is what we term as R. And R is between -1 and 1. So it's not any bigger number. The highest number for R can be 1 or -1 when you go to the other side. So we can see, let's say our R is on the number line like this. So the lowest form of R we can get is -1, and the biggest number we can get is +1. So we are going to learn how to interpret this. So let's say here is 0 that separates them. So we are going to use this to analyze and give a better description of R. So when you calculate your R, then you are going to comment on the correlation coefficient. You will use what I'm about to teach. So R is between -1 and 1. When you calculate and you get R is equals to -1, for instance, on your calculator, I will show you how to use your calculator to get the correlation coefficient. So once you calculate it and the answer is equals to -1, -1 means that when you are going to give any description to talk about R, you will say it is perfect. It is perfect negative correlation. Perfect negative correlation. Perfect negative correlation. That is negative 1. R is equals to negative 1. When your R is positive 1, you say the same thing. R is equals to 1, positive 1. So you also give a reason. The reason is what? Perfect positive correlation. This is how you write perfect positive correlation. What does it mean on the graph? It means that when you have a scatter plot in this form, y and x, that means let's say you have a point here, point here, point here, point here, point here, point here. When you draw the line of best fit, it will pass through all the points. When you draw the line of best fit, it goes through all the points. There's no point that goes outside the line. This is perfect positive correlation plot on the scatter plot. And then the perfect negative correlation will be this way, that way. So when you draw the line of best fit, it goes through all the points as well. Okay. This is how we get perfect negative. So here R is equals to negative 1 and R is equals to positive 1. So you can see the perfect positive correlation and then the perfect negative correlation diagram. So when you draw the least square regression line into the scatter plot and it passes through all the points, there's no point that falls outside, then of course you have a perfect correlation. It's either positive or a negative correlation. So that is the meaning of that. Now let's go in between here. Let's say we've got 0,5. Your R is 0,5 negative. You calculated your R and R gave you R is equals to negative 0,5. And they ask you to comment on the correlation coefficient. So if R is equals to negative 0,5 and you are going to comment on it, then here you can say it's moderate. It's moderate negative. Always look at the sign that comes with the number and write it. Moderate negative correlation. So it's correlation like that. Moderate negative correlation, 0,5 negative. So if it is positive 0,5, in other words, you will say is moderate positive correlation. That is how you write it. Now let's say before then, from 0 on the number line, I said it ends at 1. Okay, negative 1 to 1. From 0, let's say you calculated your R and your R is 0,4. Negative 0,4. And then here is 0,4. R is equals to negative 0,4. It's not approaching 0,5. So in that case, you will say your definition you give to negative 0,4 will be weak negative correlation. Just master this and your life will be easy. Before it reaches 0,5, we call it a weak negative. And then if it is positive answer, which is before it reaches 0,5, you can say weak positive correlation. So we got weak negative, that is numbers between 0 to 0,5. Is weak negative correlation. Weak positive correlation, numbers between 0 to 0,5. Now let's say your R now is 0,6 for instance. So I hope you are following what I'm doing. Your R is 0,6. You calculated R and then you get R is equals to 0,6. Still, you will say moderate positive correlation. Moderate positive. So here your definition will be moderate positive correlation, and vice versa. Vice versa means when you are also having a negative 0,6, you will still say moderate, negative correlation. Now let's choose R, say 0.98. You can simply see 0.98 is approaching positive 1, and so the correlation is strong. It means most of the scatter plot will come closer to the number line. Most of them will come closer to the number line. So R is equals to 0.98. Here you will say very strong or strong, very strong positive correlation. So this is how you give very strong positive correlation, or you can simply say strong positive correlation, and you are not wrong. So in other terms, if R is also going to if the graph is a negative slope, and then you are getting R to be, let's say, negative, R is equals to negative 0.98. In that case, you also use the same definition, but then now, instead of writing positive, you put negative there. It's a very strong negative correlation. So grade 12s, this is how far we are. But then now, before I go, one will ask, how do we determine R? The same way you determine your A and your B, the same way you determine R. So when you capture the data, capture the two data, the X and the Y values, and then store to AC, go to shift 1, and then you choose regression, which is REG. On the calculator is option number 7. When you press on this, you go and look for R. R is also part of A, B, C. I think it's option number 3. So on option number 3, they have written R there. You choose your R and you press your equal sign, and then you will get your R. And then from there, they will ask you to maybe give a comment on the correlation coefficient, which is R. So when you are talking about then you use this scale and the definitions I've given. So if your R says negative 0.98, then your definition that you use to describe this will be very strong negative correlation. That is how far we bring our lesson to an end, and then I expect that you master it. It's just 10 minutes to do the grade 12 part, which is about 10 to 12 marks in your question paper, and it happens to be question number 1 from paper 2, so you must take note of that. Sometimes they can ask you to identify an outlier. If they ask you to identify an outlier, let's say I give you a point here, we don't calculate, you go straight to the graph. When they ask about outlier, go straight to the graph. Let's say this is your graph and this is the point. And then there's another point here. So here, let's say the point here is 14 and the point here is 10. They want you to identify the outlier. Go straight. You can see all these points are clustered around the correlation, around the equation of the line of the best fit. When you draw your line of best fit, it will come around this point inside here. So now this point here is far away from the points that we're given. So this point is where we call an outlier. So here we have outlier. So now when they ask you to write down the coordinates of the outlier, you just mark here, you come there, then you can see X value is 10 and the Y value is 14. So your outlier is on the coordinates 10 is to 14. So it will always show itself on the graph. So when they ask you, it's only 1 mark, you just write it. And this brings us to the end of the lesson. Stay tuned for more updates, and I'll put more questions next time on regression analysis so that you'll be able to hammer it in your exams and get distinctions for us. If you are first time watching, or if you are always following us, don't forget to share, like, and comment so that we can assist you wherever you don't understand. Maths for You with Branco is just super. is Favavum. You're going to love it, and it's Ayoba. You see, take note. Bless you. Love you. Bye.